Start the discussion. I mean, I will share my screen as well, maybe in 5 minutes. Yeah.
Yeah.
And but before that, I would just like to see the faces of people who are here. If you can, just turn on your
Yeah.
cameras so that I know that people are out there. Yeah, real people and not just zombies. Yeah. Okay.
Yeah, we request everyone to
Yeah, we request. I
Yeah,
think
just
switch
to
on the
see.
video.
Turn on your videos, please.
I hope there are too many like young blood is there, so they would love to interact. So I request
Just
everyone.
for
ഇപ്പൊ എങ്ങനെ എവിടാ ചെയ്യുന്നത്?
എവിടെയെങ്കിലും പ്രസ് ചെയ്താൽ മതി. Shamla will come up. Yeah. That's great. Oh, a lot of youngsters out here.
I was telling, yeah, we request all the audience to put their messages in the chat box,
Yeah.
so that we can ask those questions to you directly
Perfect.
once the presentation is over.
Perfect. So
Sir,
you can close your video now. I mean, it's
Yep.
cameras now. So I will start with the general note on heat waves. So when Shivam, Tanisha, and all talked to me about heat waves first, I mean, initially I was asked about marine heat waves, I think. Then when they were, just mentioning as heat waves, I thought about they were referring to heat waves over the land. In which way, I would like to talk about both heat waves over the land and over the ocean as well. Yeah. So we will go back and forth between ocean and land. I mean, we'll talk about the general climate system, climate change, heat waves in general, and so on. Yeah. But I will start with my, more of a, I will start with from the impact on the society and then get into some science. And then, as an individual, as an youngster, as an individual, or as a community, what we can do about it. So we can talk about all those things. I will show a few slides as well. These slides I put all together in a quick short time. So I might skip through some slides and all. But anyway, starting with heat wave. So heat wave itself, we have, like Tanisha was saying, the marine heat wave is relatively a new thing, right? And so what happened is once the term marine heat wave was here, we had to, kind of separate the heat waves over land. So what do we call them? We call them terrestrial heat waves. Yeah. So I will use those terms, both terrestrial heat waves and marine heat waves. And if I say just heat wave, it is heat wave over the land. Yeah. And so what happened was this year in April, there was a heat wave, a very short heat wave. And there were some deaths. Yeah. Climate change costs lives and livelihoods. And so I'm sorry to start with a depressing story. Yeah. So sometimes it's inevitable. Yeah. But there are ways forward, and there are very positive ways also ahead where we can save these lives. That is the message of the entire storyline that I'm talking about today. Yeah. Very beautiful stories where we can even as an individual act and come out of this and save lives and livelihoods. So in February, so I work in Pune. I work in an institute called Indian Institute of Tropical Meteorology, IITM, which is more than 60-year-old institution under the Ministry of Earth Sciences. We have about 150 scientists working here, working on different aspects of the climate system, on the monsoon, on heat waves, extreme weather events, and so on. Yeah. And yes? Sorry. So all of you can mute your mic. Yeah. Thanks. So what happened was that in 2023, that is this year, April, around mid-April, nearby Pune, in very close to Mumbai, there was an incident where about 14 to 15 people died due to a heat wave on a single day. Yeah. And this was this happened because there was a big gathering of about 4 to 5 lakh people for an official government ceremony in an open ground. Yeah, I think this was around April 16th or something. Yeah, 4 to 5 lakh people gathered over there, and this was a kind of a heat wave day, and like I said, 14 people died. Yeah, and the media contacted me. I generally communicate science to the media, so many times media and journalists contact me on the science about it. Yeah, and to ask how this heat wave happened and all those things. So I usually communicate on how, what kind of weather event conspired that day to result in this kind of impact and so on. And this time, I was asked to write a kind of editorial kind of article about this heat wave. So I thought I will investigate on what actually happened, both the science and other factors as well. Yeah. So if we go back 1 year, in 2022, we had a record-breaking heat wave actually. If you remember, human memory is actually quite short. Okay, so we keep on forgetting many of these events as we move forward. So we have to be constantly reminded using data or some charts, or somebody has to tell, or some news clippings we have to bring out every time. Yeah. So and last year, starting from February, it was not a few days or week-long heat wave. It was not a month-long heat wave. It was a season-long heat wave. February, March, April, May. It was covering a large area last year, 2022. Yeah, and the heat wave was regions like Delhi reached temperatures of above 49.5 degrees Celsius, very close to 50. And in the Pakistan region, where we have observations, the heat waves reached about 51 degrees Celsius. Yeah. And if you think about that, many of these regions do not have any ways to adapt at all. Yeah. And even if you think we can use air conditioners, many of these places do not even have electricity. Yeah. So this was a condition, and this was like April, May, when heat waves at the peak, and even it affected agriculture also. Wheat exports, everything was largely affected during this period. Yeah, and now I want to move back to this year again. Compared to last year, that April was not quite hot. The temperature in that area near Mumbai, the temperature was around 34 degrees Celsius. Yeah. So compared to that 50 degrees Celsius or above 40 degrees Celsius, temperature was between 34, 36 degrees Celsius. The humidity was also high. Yeah. Now, regarding the temperatures and the humidity, yeah, these measurements that I'm talking about, these values that I'm talking about, are from the nearby station. When we say nearby station, it is like 50 kilometers or more away, which means that we do not have the real values of measurements of temperature where this event occurred. Yeah. So in fact, much of the understanding that we have in terms of high temperatures, high humidity and all are from approximations from nearby stations or from satellite values, which are not always accurate, which do not capture the peak values and so on. Yeah. So we will get into all that. So despite having moderately high temperatures, the temperatures were like 2 to 3 degrees Celsius above normal. How did these people die? So in climate change, we talk about not only the extremes in weather, but also there are other factors which kind of amplify the impact. One factor is the vulnerability. It can be vulnerability of the person, vulnerability of the region, or in terms of adaptive capacity and so on. The other factor is the exposure. Yeah, exposure to these impacts. For example, suppose sea level rise is happening, right? So who is exposed? People on the coast are more exposed, and who on the coast? The low-lying regions, than the high people in the high-rise altitude regions, right? So that's kind of the exposure. Vulnerability comes with respect to it's all mixed up, but vulnerability also comes with respect to the health of a person, the age of a person, the income of a person, many things, education of a person, right? All these things. So if we looked at those factors, the exposure, vulnerability, and all, some new points come into light in terms of that particular heat wave. So I talked to the collector of that region, and I got a list of these people because I wanted to see the statistics. Okay, I asked for the list of people with their age and gender. So what I saw was that out of the 40, 12 were women, and out of these 12, most were middle-aged women between 40 to 65 years old. Yeah, so most of them, all or maybe all of them, were mothers who had children as well. Yeah, and they had left their homes very early morning, maybe the break of dawn, and gone to this travel. These are from different parts of Maharashtra and traveling to a place called Navi Mumbai, Ghatkopar or something, that area. Yeah, early morning to attend this morning ceremony in the open grounds. So you have to remember 4-5 lakhs of people had got together. There was a huge ground. Yeah. So what happened that day was these women and all were packed in tight population for hours and hours. And you know how the government ceremonies are. You announce at a particular time and it happens after several hours. Yeah. So they were under the blaring sun for hours and hours, and without access to toilets, without access to water. Yeah. And they were not even probably able to talk or raise, if they were in a particular condition, raise the, urgency of their condition. Yeah. And due to that, the vulnerability and exposure more than the heat and the humidity. Yeah. Generally, when heat and humidity combines, it can be a death knock. Yeah. And this time all of these factors conspired together. Yeah. So when you have high humidity, and if the temperature is also high, so what our body does is if there is a heat stress condition, our body expels the heat through sweat, and the sweat evaporates, so the body cools. Yeah. But when there is high humidity also outside, that mechanism, that sweating evaporation mechanism fails. Yeah. So the thermal regulation of high temperatures fails. Yeah. So that way the body is unable to regulate the temperature. Yeah. And it results in the multiple organ failure, and person dies. Yeah. So duration of such high temperature and high humidity cases are much more now, which results in such kind of high impacts where people are dying. Yeah. So how did it affect me? When I saw these people, the names of people, I understood that okay, these were people who were living just like me, middle-aged person. Yeah, they were living, just a few hours or a few days back, they were living person. They were mothers or a family person. They were living with a family. They had relatives and father and mother and children and so on. And one fine day, because of just, not just due to climate change, but largely because of lack of precaution. Yeah. Lack of awareness, lack of precaution, people had to lose lives. So if any message I'm going to give through this presentation and talk, it's that whether it's climate change or extreme weather events, if we take some precaution beforehand, because we are living in a era where we have a lot of awareness about what extreme weather events are happening, which regions are hotspots, what kind of data is, I mean, there's a lot of data being churned out with both observations and models for both for the past and the future, and also in terms of forecast. We can really use this to equip people in terms of whether it's for evacuation, whether it's for adaptation, multiple ways of acting in terms of extreme weather events. Yeah. So I will first share a PDF. It was an article that I wrote. This came out in Friendline magazine. Yeah. So that time the entire region was going through that heat wave period, so let me move to the next page. So you see this photo of that gathering. This is a photo, aerial view of that photo of huge population. Yeah, this is that from that ceremony where those many 14 people died. And sorry, these are, the names of that people. You can see that a large number. Yeah, I think about out of 14, about 10 were females. Yeah, between the age of 40 and 60, 65 and all. So when you see these names and people, then it hits you. And until then, I was like, I used to always, try to approach these numbers in terms of heat waves and all clinically. But when I saw these names of people, then it hit me really hard. Yeah. And so, yeah, I'm trying to, yeah. So those are heat waves over, large scale heat waves. Then there are heat waves over the land called urban island heat waves, okay, or urban heat wave islands. So this is a map from the satellite which shows the land surface temperature, okay, and let me see. Yeah. So you can see Delhi over here, right? So this is very close to Delhi, yeah. And on the upper left, you can see the color scheme. The red temperatures are 35 degrees Celsius, and blue are going up to 15 degrees Celsius. And mind you, this is nighttime temperature. This is not daytime temperature. Okay. So what story does it tell? So generally, daytime you receive the the solar energy, the sun's heat as short wave, yeah, and it can penetrate through many matter, and it reaches the earth and heats up. In the night, this heat energy mostly goes back as long wave energy. It reflects back as long wave energy. But in those concreted areas, in those urban areas where there is no open space, yeah, the heat, the long wave energy gets trapped up, yeah. And you can see those hotspots like in Delhi, all those urban areas, Rohtak, Sonipat, Panipat. So yeah, where the heat gets trapped up even during the night time, yeah. But the open areas or the rural areas where there are agriculture space or open areas, you can see the temperatures are cool. So the difference between these two are up to 15, 20 degrees Celsius. Yeah, which means that even during nighttime, during a heat wave, this is a single snapshot on May 5th. Yeah, so even during nighttime, temperatures over urban spaces do not cool down because of that urban heat and thing. Yeah, so at some point you can go through this article. It's uploaded on my website as well. It's called Death by Degrees. Yeah. So let me stop sharing this article and get to my PowerPoint presentation. Yeah. Yeah. Just a second. Let me hide the floating controls. Yeah, perfect. Perfect. So this is my opening slide. It's comic, but it shows the state of both the state of climate and state of action as well. Yeah, the temperature is gradually rising. It's a frog in a pot scenario. Temperatures are rising, but we are saying, okay, it has been temperatures have been going up and down for centuries and all, and we don't have to worry much about. Yeah, but if you look around, we will in fact see that the impacts are quite huge. Yeah. And this is again a picture from India, from one of those heat waves that I talked about earlier. Yeah, one of the terrestrial heat waves. Yeah, and you can see how it might affect the agricultural land and people alike, water security. So generally, these heat waves, whether it's marine heat wave or a terrestrial heat wave, it affects the food and water security of the country and the lives and livelihoods of people. Nice slide. Yeah, and coming to navigating heat waves, that was the title of today's talk. These heat waves have tremendous impact. Yeah, both the marine heat waves and terrestrial heat waves as well. They impact the monsoon. They impact other extreme weather events like rainfall extremes and tropical cyclones and so on. We'll go through a few slides which kind of summarizes this. Yeah. I know there is a lot of people from non-science background as well. So I will try to keep, even though you see technical figures or images, I'll try to keep it simple. Yeah. So this is a image from the IPCC, that's Intergovernmental Panel on Climate Change, which bring out reports on climate change and so on. Yeah. Tanisha, you will be accepting other people who are entering the waiting room as well, right? Or do you want me to accept those people? Let them in?
Yes, sir, that would be better because we do not see the co-host option here. So
Okay.
That's not.
Okay. Let me see if I can, since I'm sharing now. Oh, there is only a host option, huh? So if I make you host, do you think my presentation will go?
Yeah. So we were just checking with that option. There was some technological issue.
Yes, I think. Yes, yeah. Trying to figure this out, but we were not. Yeah.
Shall I make you host?
No, we were trying to figure that out, but I think you'll not be able to share.
Okay. So let it be.
You can try,
so let us continue with what we are having. Now there are no
you will not be able to.
Okay, no worries.
Share your screen anymore.
Yeah. Let's continue. So this is. So this shows the state of our climate. Okay. So on the very lower axis, let me try to use my highlighter. There's a pointer. So if you look here, we know we start from 1850s during the pre-industrial area when the industrial revolution started, and we started emitting carbon dioxide, more and more greenhouse gas emissions, which resulted in the atmosphere trapping more solar energy and heating up the atmosphere. Yeah, and so these gray lines shows the observed period. Yeah, and these are climate change projections for the future under different scenarios. We call them shared socioeconomic pathways. So depending on the pathway that we take, if you reduce emissions, the amount of emissions on this axis will be lower. Yeah. So until now, we have emitted about 2,500 gigatons of carbon dioxide or more. Yeah. So depending on how much we reduce, yeah, the amount of carbon emissions will be larger, yeah, and the temperatures will also go up accordingly. So where have we reached? We have reached about 1.1, 1.2 degrees Celsius change of global temperature until now, yeah. So, and regardless of whichever, the blue to red, whichever pathway we take, yeah, what the IPCC says is that we will cross 1.5 degrees Celsius between 2020 and 2040. That is the current decades. Yeah. So very soon we will cross 1.5 degrees Celsius, regardless of whichever pathway we take. And between 2040 and 2060, we will cross 2 degrees Celsius. Yeah. And why is that? Because each country has committed to some reduction in carbon dioxide and all. So these nationally determined contributions, yeah, in terms of greenhouse gases, they are insufficient to keep the temperatures down, which means that to some extent, yeah, whatever we are seeing right now are going to continue, and not only continue, but also increase in the near future. Yeah. And one reason is because the carbon dioxide emissions stay in the atmosphere for long and longer time. Yeah. So this is a picture. I have put Calvin and Hobbes and all on the left because it shows whatever actions we have taken right now is going to impact not just one lifetime, but several hundreds of lifetimes in the future. Because carbon dioxide have a long lifespan. So suppose we take the carbon emissions until now as 100%. I'm going to explain this graph. So, and we stop all the carbon emissions right now. So stop your phones or the electricity, the computer in my room, stop all the cars, all the industries right now. Yeah, the carbon dioxide will go down slowly, but it's a very gradual path. So even if we stop everything at this moment, yeah, the x-axis is the number of years, okay? So even after 100 years, 40% of that carbon dioxide will still remain, trapping extra solar energy. And even after 1,000 years, 20-25% of that carbon dioxide will remain, because the mixing and absorption of carbon dioxide, yeah, is very slow process. First, the atmosphere uptake is there, then the land uptake is there, then the ocean absorption is there. It's a very slow process whereby the carbon dioxide gets dissipated, yeah, which means the carbon dioxide have a long lifespan of thousands of years. Yeah. So that is the impact of more greenhouse gas emissions. Now, this is another figure. Again, it might look technical, but on the y-axis, it shows the energy absorbed by different Earth system components. Yeah. Let me accept the people who are in the waiting room. Yeah, wait all. Yeah. And on the x-axis, we have the years. Yeah. So since the last 50, 60 years, it shows how much energy in terms of heat has the globe absorbed. Yeah. And all the blues here are actually the ocean, different layers of ocean. So if from our understanding, we know that oceans take up more than 90, to be exact, 93% of the additional heat from global warming is in the oceans. If oceans were not there, actually, we would have been, you know, we wouldn't have lived long over land. Yeah. So this is because ocean have a huge, water has something called the specific heat capacity. The heat capacity of water is huge. And also, not only that, oceans cover a large area. Yeah. So the atmosphere, land, ice, and all absorbs only less than 7% of the heat gain from the oceans. And to put it in very layman's term, the extra heat. So this is the additional heat absorbed by oceans due to global warming. It's equivalent to 6 Hiroshima atomic bomb detonations per second. Yeah. So you can imagine the amount of heat uptake or absorbed by oceans. Yeah. Now, I will skip this. This technical. Yeah, I'll skip this. Now getting on to our region. Yeah. So most of you are from the Indian subcontinent only, or mostly from India, I guess. And if you look at this region, this is the Indian Ocean region, which I have highlighted here. Now, why is this map looking slightly different? It's because it is conflated based on population of each region. Yeah. So you can see India is bulging, Indonesia is bulging, yeah, Bangladesh, and so on. And this is because these regions have the largest population, whereas United States and other countries are quite smaller. Even Africa is smaller than what we usually see in a map. So 1/3 to 1/2 of the population is in this highlighted area. We call the Indian Ocean region. And this is also one of the regions which has the fastest warming ocean temperatures. And if you look at India, it is, on the north, we have the Himalayas, which is fast changing, the glaciers are melting. And to all the three sides, we have the Indian Ocean, which is like one of the fastest warming ocean. Yeah. And it's basically itself, climatologically or normally itself, it has some of the warmest waters, and these are the warmest waters which are warming at a fast rate also. Yeah, which is why that region is quite important. And now, if you look at the impacts over this region, the larger Indian Ocean region, many regions have been impacted by floods and droughts and wildfires and famines. That is one of the impact. Cyclones and storm surges, we have been hearing. Storm surges are huge waves, because of the cyclonic winds. They push huge waves of up to the height of 5 to 10 meters or so, onto the land. And another one impact are the terrestrial heat wave, which are mostly towards the northwest Indian region, and similarly marine heat waves, which lead to coral bleaching and all. So many impacts due to climate change are happening. Phytoplankton, the base of the food chain. Yeah, these are microscopic plants in the ocean which sustain life. And also, if you take a deep breath, more than 50% of the oxygen has been evolved from this phytoplankton over millions of years. Yeah. So those phytoplankton are reducing because of ocean warming. Sea level rise, and we think about sea level rise from the perspective of glaciers melting or ice caps melting, right? But over the Indian Ocean, over this region, 50% of that is actually due to the ocean warming. Yeah. Because as ocean warms, the water also expands, the volume of water expands. Yeah. And the oceans have huge volume of water, and that water expanding also results in sea level rise. So, which is why we have uneven sea level rise and so on. Yeah. I'll skip some of this. And coming to marine heat waves, I told you that oceans are absorbing a lot of heat, more than 90% of the heat from global warming. And some regions, sporadically, marine heat waves are not like periodic events where we can predict much well ahead. Yeah, they are quite sporadic. At many locations, they are sporadic, and some might last for a few days to few weeks to months. There are some heat waves like over the northeast Pacific. Yeah, we used to call it the blob. This is called the blob, and this was identified some 5-6 years back. Yeah, and this blob used to last for a year or more. Yeah, and sometimes it appears, sometimes it disappears, and this had huge impact on the fisheries and kelp over this region. It in fact impacted the U.S. fisheries. It resulted in a short-term impact on and resulted in the collapse of U.S. fisheries over that region. Similarly, over the Australian coast also, marine heat waves have been observed. Yeah, and this was one of the first heat wave to be monitored. It occurred in 2010, and that was the first time when the term marine heat wave was coined. Yeah, to identify and distinguish it from heat waves over the land. And then we started observing heat waves over the Indian Ocean, the Western Indian Ocean, Bay of Bengal, and now in the Arabian Sea also scattered heat waves are observed. Yeah, and these are temperatures way off the radar, sometimes 3 degrees Celsius, 5 degrees Celsius or more higher than normal temperatures. Yeah. So to visualize this heat wave, here is a chart of one of the marine heat wave that occurred in 2020. Yeah. So just like terrestrial heat waves over the Indian Ocean region, these marine heat waves also mostly occur during April, May. Yeah. They occur during the monsoon season also in many periods. Yeah. But the highest temperatures occur just before the monsoon. Yeah. That is when there is a lot of solar radiation incoming on the ocean, and also there are not much clouds. The winds are weak, so it let the temperatures develop. Yeah. So let me explain this chart. Yeah. On the x-axis, you see April, May. The dates are there, 1st April to 30th May over here. And on the y-axis, you see temperatures from 28 degrees Celsius to 32 degrees Celsius. Yeah. And the blue line here should be the actual average temperatures over this region. So this is a region somewhere in the Bay of Bengal, yeah, where there are corals and marine ecosystem, fishes and all. Yeah. So the average temperatures during this season, April-May season, should be straddling between 28.5 degrees Celsius and 29 degrees Celsius. Yeah. Yeah, much below 30 degrees Celsius. Yeah, these are generally called temperatures above 28 degrees Celsius are called warm pole temperatures. Yeah, but on that year, April, May 2020, what the real temperatures that happened were this. If you follow this black line, those are the real temperatures that occurred during those months. Yeah. So you can see it started from 29 degrees Celsius, then going down, going up, going down, then again going up, yeah, reaching 30.5 degrees Celsius, then again going down and up, 31 degrees Celsius, reaching almost 32 degrees Celsius, yeah. So all these red periods, yeah, those days with the red periods are marine heat wave days, yeah, because they are above the statistically 90th percentile. So we use statistical thresholds, yeah. So those temperatures which are in the top 10% of the long-term average for the last 40 years or so, we call them, which are above the 90th percentile, we call them marine heat waves. And if they last particularly for 5 days, 3 days or longer, yeah, 3 to 5 days or longer, yeah. So you can see that this can be considered as one marine heat wave, where that high temperature of 30 to 32 degrees Celsius, yeah, stayed for almost 1 month, yeah. And if you compare with the average temperatures, the maximum difference is up to 3 to 4 degrees Celsius. Huh? And then what happened? A cyclone happened. You might have heard about this cyclone called Cyclone Amphan, yeah, which was one of extremely severe cyclone to happen in the Bay of Bengal, yeah, and had huge impacts on the east coast of India. So our studies show that many research shows that these high temperatures provide consistent supply of heat, energy, and moisture for these cyclones to intensify rapidly. Yeah. So what happened with Cyclone Amphan? So I remember that one day it was a very weak cyclone, and people go to sleep thinking that it's a weak cyclone of maybe 100 km/h speed. You compare that to a car speed or something, like a car going at 100 km/h speed. Even that is a quite fast, right? Strong wind. Yeah. Now, the next day, when you wake up, yeah, the cyclone has already transformed to an extremely severe cyclone of 220 km/h speed. Yeah. We are talking about the intense wind of the cyclone. Yeah. So your roof is already gone because you were thinking that it was a weak cyclone and you were not prepared. Yeah. So that is the kind of intensification. We call it rapid intensification when a cyclone intensifies from a weak cyclone to an extremely severe cyclone in less than 24 hours. Yeah. So these marine heat waves are leading to such intense cyclones, yeah, over a short period. You see that once the cyclone forms, because of the strong winds, the temperature goes down, but still it goes back again. Yeah. So these are the kind of marine heat waves which are occurring over the ocean. Now I'm putting that same thing spatially here. On the left, you have that chart, same chart which we saw earlier. On below, we have the ocean temperatures. SSTs means sea surface temperatures. On the left, we have the usual, how it should be usually. Yeah. So the light colors like yellow to orange colors show 28 to 30 degrees Celsius or so on. Yeah. So compared to the normal conditions, the temperatures during April, May that time went up to 32, 33 degrees Celsius. Yeah. Which is quite high. Yeah. Now the one on the left is actually average temperatures over a box. So you won't pick up these high temperatures. Yeah. And this not only cyclones, these marine heat waves have huge impacts on the ecosystem as well. So this picture here on the top left is actually from a Netflix video called Chasing Coral. On the left of that picture, you can see those bright pink colors, right? This is before a marine heat wave happened. Yeah. So corals have this mucous membrane called zooxanthellae, which gives their shield and also their color. It protects the corals from high temperatures and also from other harmful conditions. But when there are very high temperatures, which it cannot tolerate, this zooxanthellae, this mucous membrane, get bleached away. That's what we call coral bleaching. So it appears white or dirty in color. That's what happens when a marine heat wave happens. Yeah. And if it happens again and again, the corals get killed. Now, why are corals important? Corals occupy only 0.1% of the globe's surface, but more than 25% of the marine species are dependent on corals. Yeah. So that's why these marine heat waves are quite important to understand, because if you consider the food security, the fisheries sector, or even the bio ecosystem, the marine ecosystem, yeah, they are being severely impacted. Just like how I showed the humans over the land. Yeah. So I talked about those women who could not speak during those heat waves. Just like that, these are ecosystems which cannot speak for themselves and are being affected by the heat waves. Yeah. And the temperatures during these heat waves are much beyond that what we actually saw earlier. So earlier I had showed a chart, which is on my top right, but this is the chart. I mean, that is the data from satellites, yeah, which kind of averages these conditions. Now, this chart is from of the same period, but from a buoy, a floating instrument in the ocean at one location. So it recorded temperatures up to 33, 34 degrees Celsius, yeah, which means that the temperatures are much higher than we ever thought. These are record temperatures in the open seas. Usually temperatures are 28, 29 degrees Celsius, but marine heat waves are going off records. Yeah. So this is the kind of marine heat waves that we are facing. I think I won't share more of these slides because I can keep on going, but let me come back to my so let me spotlight myself. Yeah, so these kind of marine heat waves have been occurring over and over. Yeah, and this year global ocean temperatures totally went off charts. Yeah, not just in the Indian Ocean but also in the Pacific and in the Atlantic, in the global oceans. There are record temperatures both over the ocean and over the land, and about 30 to 40% of ocean temperatures. Yeah. So last time I checked, it was around 30%. They are experiencing marine heat waves right now. Experiencing marine heat waves. Yeah. And we know that since 2000s, in the last 20 years or so, more than 90% of those marine heat waves are due to global warming or due to anthropogenic or human-made carbon emissions. So it is very clear, yeah. Models have and data have clearly shown that these are due to anthropogenic emissions and so on. So how do we go about it? The first way is to definitely reduce emissions, yeah. But the problem there is, so that is what we call climate mitigation. Yeah, there are two ways of primary ways of acting in face of climate change. One is climate mitigation, the other is adaptation. Now, the problem with mitigation or reducing emissions is that when we talk from a individual perspective, it has gone beyond the level of an individual or beyond the level of community or a village or panchayat, or even beyond this level of a state or nation. We need the globe to act together and reduce emissions. Yeah, even one country reducing emissions won't help. And like I showed earlier, so far countries haven't started acting in terms of reducing emissions. And carbon dioxide is piling. We will see more heat waves over the land and over the ocean as well. Yeah. And these are impacts, they change the atmospheric circulation, affects our monsoon, results in extreme rainfalls because there is more energy in the atmosphere, yeah, from this heat. There is more moisture. Warm moisture, is kind of lighter. It moves around faster. It makes more fluctuations in the atmosphere. So it changes the global atmospheric circulation. So we have erratic weather, yeah. And because of that, the events, extreme weather events are going to continue. Yeah. So which means that the impact of these heat waves, marine heat waves, ocean warming, and so on, doesn't stay there. Yeah. It reverberates through the entire atmospheric system. For us, the changes in the Indian Ocean affects the Indian subcontinent as well in the form of monsoon, because the monsoon derives its source of energy and moisture from the ocean, and then bring those rains and the moisture from the ocean to the land, to the subcontinent. Yeah. So any change in ocean conditions, ocean temperatures, will affect the monsoon. So there are more fluctuations. So one particular change in monsoon pattern is that, so this is again with the physics and chemistry of the how it works. So as the air warms more, it can hold more moisture. Yeah. And we know that the air temperature is warming, so it's holding more moisture. And there is more moisture available now because of global warming from the oceans, because it's evaporating. Yeah. So the air holds this moisture for a longer time because the holding capacity becomes more and more. Yeah. Because it's warmer, it holds more moisture. So it doesn't rain for a long time because that air is holding that moisture. Clouds start building up and it stays for long. So we have long dry periods. And then when it rains, all that moisture absorbed, yeah, is dumped in a short spell. So we have periods of like weeks, days to weeks when it doesn't rain. And then suddenly in a day or a few hours sometimes, all that rain dumps in a in a small region. Sometimes it's like cloud-based. We already got events like this year. Like the monsoon was very late to start. There was a huge deficit. Monsoon was like 2 weeks or more late actually for many regions. So it affected the agriculture. We have clear indication how it is affected with ocean temperatures, along with other factors as well. And then over a few days, we got heavy spells of rain. Even in Pune, last few days, we had heavy spells of rain. Actually, record rain of the monsoon season we got the day before yesterday. And even today, just before coming to this talk, we got a heavy rain spell. Yeah. So these kind of cloud-based like kind of events are increasing. Yeah. So, and this is all in response to that 1 degree Celsius temperature change that we saw until now, and due to the emissions from US, Europe, Russia, Japan, all the developed countries during 1850 to 2000s and so on. Now China and India has joined that bandwagon, and it's going to 1.5 degrees Celsius, 2 degrees Celsius, and so on. So we really need to think of ways of adaptation, and whether it is the marine ecosystem, oceans, and so on, or over heat waves over the land. Yeah. So I think we can talk more. I think we already taken a long time. We can get into this conversation mode with both the host and you, the participants, and then go into more details about these heat waves and what we can do. Yeah.
Yeah, thank you for that really informative presentation. One thing I wanted to just ask, like as you said, like marine heat waves are like very like sporadic in nature. You can't really predict them. How do we? But of course, they're going to intensify,
Right.
and there are going to be more of these events. So how do we prepare for them? What kind?
Yeah. So, though I said many are sporadic, so one aspect that we found about marine heat waves are they are more relevant during El Nino years. Hello, Tushara, can you mute your mic? Anyway, so
Harshita, you can I think mute them. You're the host, right?
no, I'm not the host.
No. Harsh, I was talking to Harshita.
Yeah. Sorry.
Yeah.
Yeah. Perfect.
Yeah.
Perfect.
Sorry.
So many of these marine heat waves are in fact tied up to some modes of climate like the El Nino. Yeah. So during El Nino years, El Ninos are like when the ocean tries to throw up its heat that it absorbed to the atmosphere of the climate system. El Ninos occur as warm water events in the Pacific. Yeah. So when these El Ninos happen in the Pacific, it changes the atmospheric system and drives, similar kind of hot water or warm water events in the Indian Ocean also. So I'm not going to explain the entire physics of it, the dynamics of it, but many events, many heat wave events in the Indian Ocean and other basins correlate well with El Nino events as well. And there is some predictability in El Nino, in predicting El Nino, and concurrently with the marine heat waves as well. Yeah. So there has been attempts from NOAA, which is the National Oceanic Atmospheric Administration in the US, and also Indian institutions like INCOIS, which are both monitoring marine heat waves, the high temperatures in the ocean, and the coral bleaching as well, and also trying to forecast them with ocean models and ocean atmospheric climate models and so on. So there is some improvement in terms of forecasting, but some of these events may be beyond these forecast models because they are not even monitored very well. Yeah, because we do not have enough instruments in the ocean to monitor many of these events. Yeah, so without that, forecasting these events are a tough challenge. Also, it also prevents us from forecasting weather events like cyclones accurately, because you see that these marine heat waves impact cyclones as well. So if a cyclone is going to intensify rapidly over the ocean, yeah, the weather models that we have should have correct information about the ocean temperatures, which are supercharging this cyclone. Yeah, so we do not have those information as well. So we need to actually invest more in the ocean, of monitoring the ocean, so that we can, forecast not only marine heat waves, not only monitor and forecast marine heat waves, but also the extreme weather events which come towards land as well. Yeah, and I would say what our climate projections are showing is that regions like Indian Ocean, they are going to by mid 2050s and beyond that, we are going to a permanent marine heat wave stage, which can be depressing. So we need to actually, if we are thinking about corals and all, these temperatures will be beyond tolerance levels of tolerance range of corals. We will need to actually put more money investment into studying about corals, identifying coral species which can withstand, and their genes which can withstand high temperatures, and try for having coral rejuvenation using that understanding. Yeah, so a lot of research should go into biotechnology, in marine biotechnology as well, in that way. Yeah.
Sir, I have one question. And Bhushan.
Bhushan.
Yeah, sir, what is the basic difference between a terrestrial marine heat wave and terrestrial heat wave and marine heat wave that occurs in ocean?
So, see, the definition of marine heat wave itself is still evolving. Okay, so the terrestrial heat wave itself is different from region to region, different between Met departments and so on. So, for example, over India, over the land, over normal areas and all, we say if the temperature is above 40 degrees Celsius and the anomaly, I forgot exactly if it is like 2-3 degrees Celsius or 5 degrees Celsius above the normal, and if it stays for a particular number of days, yeah, it is identified as a heat wave over land. Basically, if it has implications on human health and comfort, yeah, that is what they target in terms of identifying a heat wave over land. Yeah, many times, and that is based on that the bulletins are also sent. So these bulletins are sent by the Met Department to all cities across India. Now every 6 hourly, especially particularly during April, May, June time, heat wave bulletins are sent by Met departments to all districts and cities across India through regional Met divisions to the local administration. Yeah. So in case your district or town or city doesn't alert you, you should take that up with the local authorities, that why the heat wave alert didn't reach your region. And this is also taken up by media. This is sent to media as well. So in case the local media doesn't alert you about these heat waves over the land, then again you should take up with the local media and local authorities, because this is a quite severe thing. If the temperatures are above 40 degrees Celsius and the humidity is also high, it can impact you largely. Now, coming to marine heat waves are now generally defined based on whether it's above the,
Okay,
it's based
atoll
on the
definition, 90th percentile threshold.
yeah. So you know about it, the 90th percentile definition and so on. And now still there is no overall consensus, and also there is one problem with marine heat wave, because until now the definitions have been based on ocean surface temperatures. And we know that marine heat waves penetrates down to the subsurface, even to depths below 100 meters and even to 200 meters. These subsurface marine heat waves are, that research on that is getting evolved. So we are trying to have more understanding. So we need to actually redefine the definition of heat waves in terms of subsurface heat waves. Because the relevance on both the ocean climate system and also the marine ecosystem, the corals, are going to be different with respect to the subsurface heat waves. So basically, so far it has been a statistical definition. It goes above a particular threshold, and if it lasts for 3 days or 5 days or more, it is characterized as a marine heat wave. And some can be a smaller region, some can be wide region. So that, which is why probably it is quite different from land heat waves.
Sir, I was studying in I think Java coast, southeastern Indian Ocean. So in 2016, I got one marine heat wave that around lasted for around more than 300 days. So is that possible? And sir, is that possible for terrestrial heat wave also, that it can also sustain for longer than month
no.
and all?
So that's a huge difference actually, because the memory of atmosphere, memory of air, and the air moves quite faster. And the heat capacity of atmosphere is short. So even if which means that it can get heated up fast, but it loses heat also fast, and the air is fast moving. So the heat waves over land are generally shorter, unless, some cases like last year when there was a what we call standing wave, and the what you call there was long-term subsidence or dry air, coming down over the Indo-Pak area for quite long days. So, but still, generally, heat waves over land are generally for days to weeks, while over the ocean, like you said, what you said is correct. It can go for 100 days. I've seen in the Indian Ocean going to 100 days. Sometimes, like you said, in some sports, it can go to 300 days or more. That's possible. Particularly when in some regions, I don't know if it is true for the Java coast, some regions are fed by warm water advection from nearby regions. So warm water keeps coming, but then it doesn't go out. So this kind of, you can explore that dynamics if you are researching on that.
I'm currently in MTech, so that's my project topic, that marine heat wave. Java coast.
Good to see that. Good to see that.
So right now, I figure out that the 2016 has the longest marine heat wave from 1982 to 2021 time period.
Okay.
Along that on that particular. So right now, my future work will be to factors responsible for that. Investigate
Factors. That is quite important. And also, you see, for, I mean, at least glancingly, at least for just for your understanding, see if there are any particular impacts reported on the marine ecosystem, even if it is not part of your core study.
Yeah, surely it is parts of my study. So what
Okay.
it impact on fisheries and all. So I'm trying to find that how to get that fishing data along that coast so that I can correlate with that.
Oh, perfect. Yeah.
Right now I'm was to looking for mixed layer heat budget for factors.
Mm-hmm. Okay. Anyway, we can
Thank you.
move on to others
Yeah,
as well.
sorry.
We
Thank you,
can
sir.
discuss more, personally offline later, right?
Yeah. Thank you, Bhushan, for your question. And as Dr. Koll said, you can surely, I think you can connect and go over talks on your topic, and he'll be so happy. I have one question. As you were talking about the carbon dioxide, and recently I was hearing a talk where another climate scientist was talking about carbon dioxide, which is the major cause of global warming. And the way we have demonized it, it's also the reason why we are having an atmosphere. So it's all about how we are balancing this carbon dioxide, and it is
Exactly.
going above our balance.
Yeah.
So on that, I have a question. And actually, that climate scientist was talking about that at one point we are increasing these sources of carbon dioxide. We are putting more there in the atmosphere.
Yeah.
And the other side, we are removing more forest, which can actually absorb the carbon dioxide. So I think for the solution, find a solution to the carbon dioxide reduction or this climate change or global warming. Deforestation is a big issue. So I would like to take your notes on how countries look at deforestation, as you must be very much aware. Our government also taking somewhere deforestations are happening at very bigger level. So would you give your note on that?
Yeah, definitely. So there are two levels of it in terms of, there are people thinking that planting trees and having more trees might definitely help climate change in terms of reducing emissions or absorbing carbon dioxide and so on. What I would say is that we need huge swaths or areas of forest to actually have huge amounts of carbon getting absorbed. Yeah. So for example, if you take India, the Western Ghats region or the Himalayan forest, yeah, these are capable of absorbing, or the mangroves, Sundarbans, yeah, these are regions which are capable of absorbing large, or what we call sinks of carbon, yeah, so can absorb a lot of carbon. But at the same time, if you think, okay, in our backyard, if you plant a few trees, that can, or at the individual scale, that can make a huge difference. That may not. But at the same time, trees have another role, bigger than in terms of absorbing carbon, actually. There is what we call as, recycling the rainfall. Yeah. For example, if you have trees in an area, so for example, I can talk about, many of you might be aware of university campuses, or for example, the Indian Institute of Science campus in Bangalore, or even take my campus. These campuses, research institutions or campuses, can be large, can have large number of trees. And if you go to such a campus or such an area which has a lot of number of trees, those trees are capable of having a microclimate in terms of keeping the temperature down. So this connects to my urban heat island thing that I talked earlier. Yeah. So if you have a lot of concretized areas without trees, yeah, with skyscrapers and all, it traps that heat even during the nighttime. So the temperatures are quite high even during the nighttime. But if there are trees, at least in some areas scattered around, or if you have a huge campus with open spaces and all, that heat gets dissipated. Even the trees help its layers of vegetation helps it to disperse that heat back into the upper atmosphere and so on. So there is that reduction in terms of increasing heat or adapting with heat waves and so on. So that is one thing about the trees. The other factor is that the roots of trees reduce the runoff, so keep some of the water in those areas when we have rainfall, yeah, and it absorbs this water as well. And there is a process called plant evapotranspiration. So it absorbs that water and slowly puts it back to the atmosphere. Yeah. So it's not like if there was no tree, that water would have fallen and either got into a canal and then washed off into the sea, or that water gets evaporated quickly. Yeah. But if there are some trees, it can absorb that water and slowly put it back to the atmosphere. So that helps in forming clouds again, and resulting in more rains. Yeah. So this is again from a large forest perspective. Yeah. For example, regions like Western Ghats. So there was a study from IIT Bombay that showed that recycled rain from Western Ghats region. Yeah, it's not necessary that the rain falls there itself. It supplies 10 to 20% rainfall to regions like Tamil Nadu in the East Coast. Yeah, so that's the magic. So we talked about the monsoon winds bringing the water moisture from the ocean, then falling over the subcontinent, over India and all. So that happens in the beginning months of monsoon, like June, July, and all. Yeah, and after that, through this plant evapotranspiration, these trees absorbs a lot of water and releases it slowly, and then that rains again. It's called recycled rainfall. It happens over the Ganges region also, in the Himalayan forests and so on. So these benefits of trees are much more huge, and are much more important, particularly when we think about water security and all. So suppose we have I told you about the monsoon patterns changing, long dry periods and heavy rainfall. So some rainfall happens, instead of that water getting immediately evaporated or flushed off into the sea, the trees can help in spreading out both over the land and the atmosphere slowly, so that even during the drought period, yeah, some water is spread out and remains in the over the land region and so on. Yeah, so that role is much more larger when I think about trees and forests. Now, if you want the trees over land to play a huge role in terms of absorbing carbon, we need to actually protect our forests, like Western Ghats, Himalayan, or the large forests over India. Many forests are actually they are degrading due to encroachment and deforestation. And also there has been studies showing that they are browning because of high temperatures, particularly during the summer, April, May, June period, because the temperatures are going up. So the vegetation is, drying up. More wildfires are happening because the temperatures are dry. The vegetation is also brown and dry. So it is quite fast they catch fires. So all this is happening. Yeah. And at the same time, we see forests like Amazon, which are huge sinks of carbon. They are also getting deforested. So we need these kind of large forests to stay and maybe expand, or we need to regain those forests so that they can not only absorb carbon, but also, sustain that water cycle. So sustaining that water cycle is very important. That's my opinion. And in terms of absorbing carbon, this phytoplankton also plays a huge role. Phytoplankton and kelp forests, seagrass in the coastal ecosystems. And we are damaging all the coastal coral reef, seagrass, kelp system and all. And many of this damage happen directly due to human intervention, not just due to climate change. So the forests that we think about in India or Amazon, or the green forest that we are talking about, the marine ecosystem in the oceans, they are more affected by direct intervention. There is a lot of coral mining happening. So like corals are being excavated. There are sea cucumbers tons of sea cucumbers. That's a marine species. Yeah, tons of sea cucumbers being sold because people think that it's a medicine or it's a delicacy. Yeah, and this is much more rampant and much more damaging than climate change. Actually, even if we talk about fisheries, climate change can be sometimes a distraction actually, because industrial fisheries have wiped out more species and reduced the biomass or the fishes in the ocean than climate change. Yeah. So there are these factors actually which we need to think about, whether it is land or the ocean, whether it is heat waves. So heat waves, I started with that story, right? So more than a heat wave, it was how humans took care of that situation. Yeah. So,
and I think focusing only on heat wave and trying to cover that will be like if you are in a house and trying to protect the roof and not caring who is living inside, and ultimately people dying inside, then what's the whole point?
Exactly. That's a quite important point. Exactly. Yeah. So we scientists also have that responsibility. Just one line. We scientists have this responsibility. So many times when we give scientific lectures or disseminate science, we talk only the science. And if we are a climate scientist, we say, okay, climate change is happening, so this is happening. But then we are not taking in these factors. Yeah. So politicians use that as a blame game. So they blame climate change for everything, for the floods happening in some place, for the deaths happening in some place. Yeah. Blame on climate change and fail to take action. Yeah.
Yes. Actually, on that point, I hope no one else is having question for now. I can have one more question if anyone has another question, because I have just one question connected to this political aspect particularly. Not going deeply into that, but as you were mentioning, you mentioned one big mela of an event where huge mass gathered and almost 14 people, if I'm not wrong, you were telling, right, over that. So being a climate scientist, or just being a scientist, I think that's fine now. So all those climate scientists or scientists to say how they can approach to the government, because ultimately it's come to the will of a government, and those actually who are holding these big events, or you say ultimately when something has to happen at nationwide, those who are in power, this scientific aspect should reach to them. For example, if they are holding a big event, they must be aware about heat waves, what exactly it is. So what is the solution actually? How climate scientists can go about it, and how actually this can reach to someone who are actually in power and they can actually make a change by changing some policy?
Yeah, so I will start it from a different, from a different solution first. For any climate impact, addressing any climate impact, I think it should start from communities. So, so if a community is facing more and more heat wave or potential for heat wave or a flood or extreme rain or landslide and so on, because for each region, the climate change impacts are manifested very in a localized way. Yeah. So the solutions are also many times localized. Yeah, based on the local topography, local infrastructure, local vulnerability, administration, and so on. Yeah. So we need to find. We actually need, this is what IPCC also calls for. We need collective action. Yeah, collective community action. So there are citizen science networks now forming in different regions of the country, yeah, across the globe actually, on different aspects. Some are like for bird watching and so on. There are similar groups, climate action groups for climate, addressing climate change impacts also, yeah. And there are many startups as well, startups and all, many stakeholders which are interested in supporting these kind of groups. So what these groups can do is, so you have community and local citizens who are interested in both the climate change, addressing the climate change impact and having solutions, along with some experts, scientists like me or researcher scientists like you, or some scientists identified who has some connection with the local climate change, and other experts. So even if it is a climate impact, so if it is related to landslides, we need a geology person there. If it is related to for example, river floods, we need a hydrologist there. Yeah. So the level of experts will be different depending on the kind of situation. Yeah. If it is a coastal region, it will be the experts will be different. So have an expert, scientific expert in that citizen science network, and have local administration also join with panchayats or district administration. Now, many panchayats and districts, all these LSGs, local governments, they have allocated money for climate action or environment action. Yeah. So we just need to find the right kind of people and move as a collective action in terms of identifying the climate challenges, identifying the hotspots, and then identifying the solutions that work for that region. And this is, I will say, I am already in some of these kind of citizen science networks. So I'm originally from Kerala and I work in Maharashtra. So in both the states, I am working with citizen science networks. So in Kerala, there is a beautiful example where I joined with a network based on a river called the Meenachal River. Yeah. So there they are monitoring the weather system, particularly the rainfall and the river. Yeah. So the rainfall with rain gauges and the river with river gauges. These are just scales. River gauges are just scales on the bridge, the pillars of the bridge or something like that. And rain gauges are just vessels with and along with some scales and all. And they are able to, measure the amount of rainfall. And this is installed, the rain gauges are installed in schools, yeah, along the river basin. So what happens is that when you have a heavy rainfall in the upstream, in the high ranges of this river, and heavy rainfalls, you can tell that in 2-3 hours downstream, there could be a flood, yeah. So based on this setup, yeah, so they had some rain gauges upstream in some of the schools and so on. So in 2018 or 19, I think there were heavy rains in the high ranges, yeah, and they estimated that in 2-3 hours it will flood downstream. And when they saw there was a colony of people downstream, like 50 plus kilometers away, near the banks of the river, yeah, and they asked these people to evacuate, yeah, because they know that they saw that heavy rains happened upstream. And these people, there were 70 families, and they were not ready to evacuate because when they looked, the river nearby them was not swelling; it was dry. Yeah, but with data and with information and with the help of authorities, the citizen science network people, they were able to persuade these people to evacuate, and in 2-3 hours that area was wiped out with water. Yeah, so lives of 70 people was saved because of just monitoring and understanding the weather conditions and the hotspots there. Yeah. So similarly, in Maharashtra, there are groups in Pune. So these are people living in the city, which coordinate with people in the villages. So they go to many villages and hilly areas which are landslide prone and which are exposed to heavy rains. Yeah. And they try to set up rain gauges in these hilly areas which are landslide prone in Maharashtra, and try to understand if, okay, this much rainfall happens, this is the kind of landslide that can occur, or in this hotspot landslide can occur because of the slope and other factors. So they were able to actually develop a model. So one of the first citizen science based landslide model was developed by this team from Pune. Yeah. And this was actually started by a media person actually called Mayuresh Prabhune. Yeah, so I'm working with them also. So whether it's a researcher or a scientist can, help such community-oriented activities. I'm sure. So I remember talking to at many public forum. So I see that take any locality which is facing climate change, whether it's a coastal region, close to the ocean, or in the hills, or in the Ghats, there'll be a few community members, yeah, some citizens or some researchers in that place, or somebody, some politician even. They are interested in taking up some activity. So it can be a group can be formed, and some kind of local assessment can be done. Local climate action group can be formed, and that way we can save lives and livelihoods, like I said.
Thank you. Thank you so much, sir. So, Harshita, do we have some questions in our chat box?
Yeah, Shilpa has got a question for you, sir, in the chat box. Let me read it for you.
So Shilpa would like to know what is the criteria for declaring heat wave. So the Met Department has a particular criteria, and it's different on plains and hills. So generally on plains, if the temperature is above 40 degrees Celsius. Now I don't have that definition. You can actually Google for IMD heat wave definition. Yeah. So that's for the heat wave definition over land, and if it stays for I think 3 days or more. Yeah. That's called a heat wave over land. Now, over the ocean, these marine heat waves are defined when the temperature is above 90th percentile. So it's a statistical definition. Yeah. So it can be any season, any month, and if it goes above the 90th percentile statistical level, then it's defined a marine heat wave, particularly if it stays for 5 days or more. Yeah. So that is a marine heat wave criteria. Yeah. But these criteria have to be redefined because that is based on the surface temperature, ocean surface temperature. Subsurface also we find marine heat waves, and the scientific community is still coming up with a proper criteria for defining these subsurface marine heat waves.
So this is kind of an extension for the question Shivam asked, which I wanted to say. It's a collective effort, as you said, because each person matters in this whole ordeal. So as an individual who is trying to be aware and who is trying to be responsible, how can one act on a daily basis towards this?
So
and also that is like at an individual level we can you can answer what we can do at an individual level, but also because you said heat, it isn't about heat alone. There are other factors like vulnerability, exposure. There are a lot of factors which make escape, like monitoring is one thing, but also you cannot really escape heat events. What kind of action can we should be demanding from our governments, like
exactly.
Yeah.
So I will start from my own personal example. Okay, so I think this was in 2021 or 2022. Yeah, 2022. Last year only. Last year May. Yeah, last year April May. My kids. So they started going to school after COVID. So the schools had started, just after COVID, and we were happy to send them off to school. Yeah. Because they were staying at home for a long time. We wanted to get rid of them. Yeah. But then it was peak heat wave time. We didn't realize that. Yeah. And they were coming back home by the school bus. We think they are safe. Yeah. We are happy as long as they are away from home. But then they were coming back at peak heat wave time. The school starts at 8 and ends at around 2 p.m., just before 2 or something. Yeah. And so that school bus starts around 2 and reach home at around 3. So this is the peak heat wave time. Yeah. And you have to think that these school buses do not have any air conditioning, and the hot air and the sun is blaring through the windows on these small boys and girls. Yeah, these small kids. Yeah, and they're not even totally aware of this situation. Also, they cannot process these kind of high impacts. Yeah, and when my son was coming, when he came back home, they have huge bags as well, heavy bags. He comes home and he's like in a situation where he has a heat stroke. Not exactly a heat stroke, but totally affected. So instead of going and playing, he goes into the room and just lie down just like that for a few hours. Yeah. So the impact of this heat was quite huge, even in a place like Pune, which has mild temperatures. Yeah. So what did I do as a parent? So there was already in the media, in the newspaper, there was information that okay, the temperatures are quite high. The country and also the region, the local news also shows that Pune is experiencing high temperatures and heat wave-like conditions. And there were forecasts also showing that, okay, this is going to continue. Yeah. So we generally depend on forecasts, or, observed conditions to be aware of a situation. Yeah. So which is something everyone can do. So like that, I also, even as a scientist, I need to depend on some information coming from media to be sometimes aware of this situation. So I read the newspapers and I also experience the heat. Yeah. So with these newspapers, I approached the principal of the school. Yeah. By email. We approached the principal of the school and showed that, okay, these are very high temperatures and it is forecasted for the coming days as well. So please either shut down the school for we know that after COVID we want to open the school and all, but please, considering the huge impact on the kids, please shut down the school for a few days or cut down the hours. So this made the principal aware of the situation. So many people are aware of the situation sometimes, but they need to be reminded. Yeah. So once they were reminded, she took quick action. They cut down the hours. So the kids were sent before the peak hours, sent back home before the peak hours. Yeah. And they were saved from that heat wave in the next few days. Yeah. Now, that is one of the kind of action somebody can take. Yeah. Make sure that the working hours are optimized during a heat wave condition. Yeah. When heat waves are there. And like I told earlier, these bulletins are sent across the districts and to the media as well, brief to the media also, but not all administrations, not all media take it up. So you sensitize your local media and local administration also to take up this bulletin seriously. Now, that is partially coming to what Harshida asked. Yeah. Now, I can connect well with what Tanisha said. Yeah. Now, so the story doesn't end there. It's interesting. So this was the last year's story. This year again, for some days, the heat wave happened. Yeah. Especially in Pune, temperatures were going about 39 degrees Celsius. Same situation got repeated. Yeah. And we had to again go through the process. Yeah. I mean, there were temperatures, I mean, this information coming through the media also. Those people had already died in Navi Mumbai due to those heat waves. Still, the school was working full time. I mean, this is a scenario which can be replicated across any institutions or anything, working hours for construction workers or anything. I'm giving an example of school. Yeah. So we tried to contact the principal again, but this year the principal was different also. Okay. And initially she was not ready to listen to this. Yeah. So then we sensitized other parents. Parents were also initially, they were thinking that, okay, it's just 1 or 2 days. They were more worried about academics. But then they saw their kids are also being affected. Yeah. So then we acted together and approached the principal. So the principal cut down the school hours. Yeah. So I'm sure next year also this will, if a heat wave happens, this will repeat. This cycle has to repeat. Yeah. Which is a difficult thing actually. Kids already go through this heat wave, then we, approach the principal. So why is that happening? This is happening because we do not have policy. Yeah. We should, in a country which is facing extreme weather event one after another, heat waves, floods, cyclones, coastal issues. Yeah. We need to identify hotspots and we need to have policies which can safeguard us from these extreme weather events. We have the data to clearly identify, okay, these are the months when heat waves can happen. Yeah. So April, May, take April, May. Yeah. Or early June. And if we have forecasts or if we have, weather information bulletins which says that, okay, the temperatures are going to be or are currently above this threshold, which is beyond human comfort, then we need to have a policy which says that, okay, construction workers should not be out during the day for these hours. Yeah. School hours should be cut down. Other people, particularly traffic police, or if any of those kind of people working outside should not go out during these and these hours for these and these regions which are hotspots. So these kind of policies should be in place for any local government, yeah, across the country. So we need to safeguard our country with this kind of policies. We cannot have knee-jerk reaction based on forecast. We cannot wait for forecast every year because that need not necessarily save lives and livelihoods. We need to have a long-term vision, yeah, at the government level.
And I think we need more like sustained engagement with our government. Like instead of having policies to reduce working hours, we have governments proposing, in fact, increasing working hours, which happened like a couple of months ago. Yeah.
And many times I feel even community activities are at first not supported by government, but when we show that it works, then they try to take it as part of them, so as to, they also come in place and fall in place and join the activities. So I have seen many panchayats which were not ready to help or support these rainfall monitoring or heat monitoring and all. But later, once they saw the benefits and saw that people were watching, it was coming in the media and so on, they were interested. Yeah, they were ready to use their allocated money for these activities.
Hi, sir.
Yeah.
Hi, Vrinda.
Hi, sir. My name is Vrinda. First of all, thank you for your very informative, great talk. I'm also a volunteer in the Title Foundation since last year. So coming to my question, so you have explained about the impacts and mitigation and some patterns of the heat waves. Talking about the origin point of view, how does this dynamics of marine heat waves, it varies in different oceanic regions? Means in one of your slides you have shown these are the regions that where and when
Yeah.
this ocean
Yeah.
heat waves are occurred.
Yeah. Yeah.
So it means it's not happening everywhere throughout the ocean.
Yeah.
So
Yeah.
what could be the possible reason for this variations? Like what
Perfect
can
question.
be?
Yeah. Yeah. So these are due to totally different reasons. So in some areas, it happens that the winds are weak for some days, yeah, or the winds are almost not present for 5 days or 6 days over the Indian Ocean, for example, some regions. And when the winds are not there, the evaporation doesn't happen. So the water doesn't cool. If the winds are stronger, more evaporation happens, the water suffers water cools. Yeah. So if the winds are very weak during some times, so and over the same region, the clouds may also be lesser. Yeah. So it can, so for these atmospheric reasons, atmospheric dynamics, it can bring in more solar energy. Yeah. And make sure that this heat is absorbed there itself because the winds are weak and evaporation doesn't happen. So that is one way in some places marine heat waves happen. In some places, we see that this accumulated heat are not transported because the ocean currents are not advecting out of that region strongly. Yeah. So if there is a strong current from there taking that heat away, yeah, it can cool off that heat wave. But some regions we see that doesn't happen. So basically, it is either this kind of atmospheric dynamics or this ocean dynamics. Now, climate change plays a part in that within these dynamics, when that heat is absorbed, there is more heat available to be absorbed or trapped because of climate change, which is why these marine heat waves are much more stronger than usual. Yeah. And one of the marine heat wave, along the coast of Australia and all, are in response to a ocean current called Lewin current, which goes along the coast of Australia, which brings warm water. It brings warm water, and then it doesn't get flushed out quite fast as in the same amount as such it comes in. Yeah. So that heat gets accumulated over that region. Yeah. So that is these are different ways in which marine heat waves occur. So multiple different ways it can occur due to different ways. Yeah.
Thank you, Vrinda. So there are
So thank
two
you so much.
questions in the chat box which are quite similar. They were asking if you would like to say anything about heat wave studies conducted in Kerala. They both are students from Kerala, and they wanted to know about which resolution data they can use for the heat wave.
Yeah. So compared to Northwest India, Pakistan and all, heat wave is not a major factor in Kerala, but there is an additional factor because Kerala is exposed to a huge, large amount of humidity, more moisture. The impact of heat waves can be much high considering the moisture element. Yeah. So I'm not sure of heat wave studies particularly focusing on Kerala. Maybe there are studies. I haven't come across, in detail about heat waves over Kerala, heat wave studies over Kerala. Yeah. But there are studies which have characterized heat waves largely across India that might have data and information about heat waves over Kerala like any other state. Yeah. So generally, what we see is the heat wave region is coming from Pakistan to northwest India to central to Andhra Pradesh, in a diagonal way. That's the main heat wave zone. Yeah. That is if you consider only the temperature. Now, if we consider the humidity also, these regions will be different. So I would actually like to see heat wave studies on Kerala, which involves the humidity factor as well, which can be a compounding factor. Yeah. And when IMT, the Met Department, declares heat waves, it is declared for across India, yeah, and for all states and at a district wise. So you would be able to access that information from IMT bulletins, yeah, both national bulletins. If there is heat wave for any particular location, they will specifically mention that, and this is more frequent during April, May, June, those periods, the key heat wave period, yeah. So, and you can use IMD temperature. So if you want to use it for research, you can use IMD temperature data. They have daily temperature data, which is on IMD website. It's available for download, and it's available for at least from 1950 to 2022. That's what I understand. So you can download that data and analyze for any region over India, including Kerala. Yeah, and it's available at a daily resolution at around, I think, 0.5 degree resolution. Yeah.
I think that's a good suggestion, and that will be a good study to do in Kerala, because recently I was checking statistics. So recently, in July 23, this health ministry submitted a report, the number of deaths caused by heat wave in India till July, which says around 264 deaths, and which had 45% from Kerala.
45% from Kerala. Wow.
Cases from Kerala were 45%, which was like amazing. And then the second state was Gujarat. So if you combine Gujarat and Kerala, it was making 59% of deaths of heat wave in India.
Oh,
and that too just counting only the cases reported. Yeah.
Okay, that's startling, and that means we still do not understand all the other factors that comes along with heat waves, maybe including humidity and maybe the exposure factor also. Maybe many times because the temperatures are low, like the Mumbai case, like the Navi Mumbai case, we are underestimating the conditions many times. Yeah.
Yes.
And also the fact that you said Gujarat, despite having Gujarat had the first, Ahmedabad and many regions in Gujarat had the first heat action plan because they were exposed to high temperatures. Still, they are having that many deaths, means that we need more in-depth research and also climate action and maybe policy. So the heat action plans that we have in different cities and states are still based on forecasts. They are not policies actually. Yeah.
Yes.
So we need policies which can save us.
Yeah. And when actually when I was going through this report, so there were like different reports submitted to the government, and states were not agreeing to the report. They were not taking it like, they were not agreeing that these many deaths has happened due to heat shock. But looking with the factors, obviously states will not agree, will never agree with that. So
this is a huge problem.
Accountability is also there. Number of reporting, it is whether happening or not. So this these numbers might be more, but we might not be there. So with that note, I think Harshit.
Yeah, that's a key point, because we are also looking for data of health impacts due to climate, different kind of climate impacts on both due to heat and other factors, and data is severely underestimated. That's a key problem that we have to address. Otherwise, we will have no way forward. Yeah.
And we would like
thank
to
you
thank
for this.
Thank
you for this talk, for combining heat waves, the different associated factors which we don't really think about in terms of vulnerability, exposure, social factors, and also like outlining some of the actions that we can take at both like individual levels as well as as well as through engagement with our local governments. Thank you for this talk.
Definitely. And I think, Harshita.
Yeah, I mean, we went through each aspect of it, the community effort, the scientific factor, and also the science behind it. So it was really worthwhile, and thank you for making it happen, sir.
Definitely. I'm so happy to talk with you, all of you guys. And, I mean, doing something beyond what we, learn, or like Shivam started with those publishing paper and all, right? generally scientists publish a paper and that's the end. Yeah. But I think we have to go beyond that. So whatever sector you are working, whether it's research science or some other sector, you can really play a huge role in terms of climate action. Yeah. And for a scientist like me, that gives me immense gratification. I feel happy. I feel happy. Yeah. So I think the same happiness you can have as an individual. Yeah. So yeah.
Yeah.
Same
Thank you.
happiness we feel, and definitely last time and last year this heat wave happened, and that time we were planning that session with Dr. Koll, and
Yeah.
somehow we got engaged in something, and again we heard
Right.
this news, and then I saw your
Yeah.
post on
Yeah.
Facebook. Then I just couldn't
Right.
hold myself, and we
Yeah.
just gathered together, and I was like, this time let's get it done, and we'll see actually what is happening around, why these heat
Exactly.
waves are happening, and if we can pass on to the layman by any course, that would be fantastic.
Yeah.
Thank you so much for
Yeah.
joining us.
So
We'll
definitely.
always
Please keep in
grateful.
touch and follow up on that.
Definitely.
Yeah.
Yeah, we'll
Yeah.
have further discussions also in the
Yeah. Bye bye.
future. Okay.
Yeah.
Thank you
So
so
have a
much.
good night.
See you. Bye bye.
Thank you.
Have a good night. Bye bye.
Yeah.